The reason we had that warm-up testing ordered pairs is so we can look at them on a graph. So, what are some ordered pairs? What were the ones that made it true? You guys remember? Which ones made it true?
0, 6.
0, 6 was true?
No, that was 6, 0.
It'd be 6, 0.
It'd be
Oh,
6,
0, 0,
It was 0, 4 is true. Okay. What was the other ordered pair that was true?
What if we did? No, that was 5.
Well, that -1 works. -5 is less. What are some more points that are true?
What if we did 2 with 3?
2, 3. Let's see.
3, 2, my bad.
2, 3, 2. So 6 plus 6. 2, 3, and 3, 2 work. They're the same. Okay, those both work. Give me some other points that work. Asher.
That make the inequality true.
Yeah.
-1, -1.
Yeah, we got a spot there. That is true.
-2.
-2, -2. Let's see. That'd be -4 and -6 for -10. That is true. What about all these big negative numbers down here?
Yep, -1 trillion,
Yeah.
-1 trillion.
So I want you guys to check this out a little bit.
The entire
Wait.
lower left quadrant.
That one didn't work, did it?
The entirety of the lower left.
2, 3 is 9 plus 4 doesn't work. Okay. There is a line right here. Check this out.
Wait, there's.
Oh, it's everything below that line.
And you got other spots down here that are going to be less than 12.
Wait, so there's.
So look at.
It's that line. It's that line.
Check out all those answers.
That's
I want to put this into Desmos.
Here's what's really cool. On a line, how many answers are there? Infinite. But now we have more infinite answers
infinite number of
forever.
That's like infinity times infinity.
It's like Buzz Lightyear, baby.
It's infinity squared.
There we go. Next up, you're going to do that same thing. I'm going to give you this piece of paper, though, so you don't have to draw the stuff, Micah. And the reason I'm going to give you the piece of paper is graphs can be a little bit of a challenge in notes. You are going to find points that work and find points that don't work. You need to come up with an organizational strategy, whether it's 2 colors, X's and O's, something to differentiate between points that work and points that don't work. And you're just going to look for general regions. All right? So let me hand out that paper so you can get after it again. You're going to look for ordered pairs that work and ordered pairs that don't work on each situation.
It makes
You figured this
3, 2, 1. Let's take a look.
Maybe.
X is greater than Y. Who can give me some ordered pairs that work for that? Maybe if you give me 3. Finn.
7.
7, 2. Keep going. 2 more. Yeah.
4, 3.
4, 3. That does work.
-6, -7.
8, -2 does work. Okay.
-6, -7.
We got a -6, -7. That works. Alice. 0, 0 does work because it can equal. So 1, 1, 2, 2. Are you guys seeing that? 3, 3, 4, 4. Because equal works. Are you guys noticing that? But does like 0, 2 work?
And the bottom.
No. So I'm going to try my best to draw a perfectly straight line. Nailed it. Okay. So nothing above works. So like 0, 4. None of these work. So guess what? If I'm going to shade this, everything below is what works.
Yeah.
And then the line works, but why does the line work? Because
Because it's equal.
equal to satisfies it still. Okay, let's look at number 2. I don't know if anybody did this, but if I wanted to look for ordered pairs that work on number 2, the first thing I would do is divide both sides by -2. And I have to flip my symbol because I divided by a negative. So now I'm just looking for y is less than 2. So where's some less than or equal to? So what's an answer where y is less than or equal to 2? What are some points? Let's go, Evan.
0, -2.
0, -2 works. So does 0, 2. That's kind of fun. Bob, give me some points.
I think for y, I think the -100.
-100. Okay, something that I can graph points.
-8,
-8 what?
Why?
y.
No, he means
I need ordered pair to graph a point. -8 what?
-8, y. 0,
just do negative.
0, -8. Okay, that does work. Okay. What about something not on the y-axis? Finn? 2, 2. Yeah, one of my
-8,
favorite
-8.
things to wear. What?
-8, -8.
-8. That does work. Yeah,
Everything below that line of 2.
-4 does work. Okay, what about 0, 8?
0, 8.
Anything.
Yeah, so that's the whole point. So, does this line work though? That perfectly straight line I just drew by hand? Yeah, okay. And then you guys saying everything below also works?
Yeah.
Yeah. Pretty cool, huh?
The pink goes over.
Oh, it technically does go over, but that's not the intent. Okay, 2 more. So, if 3x is less than 0, are you guys good with what I'm about to do here? I hope. I'm dividing everything by 3, so x is less than 0. Okay, so someone start giving me ordered pairs that work where x is less than 0. Asher. That I can graph.
-10.
Good one, though. -10 what?
-10.
-10.
-10, 0. Okay, that works.
-10, -10.
-10, -10 works.
-10 and -8.
That does work. Let's get off the -10 train. What are some other things that work?
-6.
I don't know if that one makes sense.
What about 0, 8?
Wait, no. No.
8 is, the 0 is not less than 0. What about -1, 2?
6, 2.
0, negative. Nope. Yeah, actually, yeah. As long as the x is negative.
Okay, so check this out.
Like, just the entire side.
Are you
left.
guys seeing we want to use this line as reference?
It's the entire left side.
But
Does the line work?
that's the one.
No, so here's what we've got to do.
This one works.
We are going to make a dashed line.
I just made a bubble line.
Because that line is still, I like that, Owen, because there is like a relationship, right? On the number line.
You like the bubbles for
Yeah.
the unfilled in bubbles for like the left side.
I accidentally did a dashed line for this one because I just did a bunch of points.
Yeah. So the dashed line is like the open dot on the number line. The solid line is like the solid dot on the number line, meaning it works or doesn't work. So this says the line doesn't work, but what does work is everything on the left side of the line forever. Everywhere where x is less than 0. So let's practice like graphing this, how we would actually graph it instead of just getting points that work. So if it's in standard form, if we want to graph a line, what's the best method?
Intercepts.
I think finding the intercepts. So if I got $10, I'm going all x. How many x's can I have?
10.
10. So that's right there. If I've got all y's, how many y's can I have? 10. Okay, now does the line work?
No.
If I get ordered paired, let's say 6, 4. 6 plus 4, is that greater than 10?
Nope.
No, so what do I know about my line? It's a dash line. Okay, because the line is still my reference point, but my line does not satisfy my inequality.
And everything above
So next, you see greater than, so you might think everything above, but it won't always be true in standard form because sometimes there will be negatives and stuff. So what's a really good point to test? The origin. And if the origin works, it better be in the shaded region. If it doesn't work, it better not be in the shaded region. So let's test 0, 0. Is 0 greater than 10? No, so the origin better not be in the shaded region. I didn't change anything. I tested the origin. The origin can't work, so shaded above the line. And here's where you can see above the line. Check this out. If you subtract x from both sides, you have y is greater than negative x plus 10. Y is the relationship up and down, right? Y on the graph, so greater than the line is what that says. So you can confirm it if you were to get in slope intercept, but I just test the origin. It's the easiest point.
What's the origin?
0, 0. Like the origin story of somebody is where it starts. 0, 0. What your job to do here is you're going to practice graphing all of these lines. As you graph them, go into it the big ideas. If they're in standard form, what should you be using? The intercepts. Then you need to consider, is my line solid or dashed? Then you need to consider, does the origin work or not? Okay, you spell it N-A-H if you're writing that down in your notes. Get after it with your partner. So, y'all, if I have all x on all these, my x-intercept is always 5 because they're all kind of the same line, right? You guys seeing that? And if I go all y, my y-intercept's always negative 5. So these are my reference points. I'm just laying them down. So the next thing I'm going to do is on the first one, John, I'm going to say, hey, is it dashed or solid?
Yeah.
It's dashed because the line does not satisfy my inequality, right? It's got to be less than. Next thing I'm going to do is I'm going to test my origin. Is 0 less than 5? Yeah, so if my origin works, I need to shade the side that my origin's on because the origin works. So for the next one, the top right, it's or equal to. So what does that say about my line, dashed or solid? Solid.
I thought you went down.
Because
Oh, that, okay.
because line works, because equal to works. Okay? I'm going to test the origin. Is 0, 0? It gives me 0. Is that less than or equal to 5? Origin works, so I have to shade above. Okay. On the bottom, greater than. Does the line work?
Minus.
No.
Negative 10.
Dash line. Let's test the origin. Is 0 greater than 5? Nope. So the origin should not be in the shady part. And the last one, or equal to means solid.
And it's the same as 0.
And 0 is not greater than 5, so the origin cannot be in the shaded region. All right? That's it. So, graph the line. Is it solid or dashed? Does the origin work? That's kind of how I go after all these. Now, what if your line goes through the origin, though? What points would work to test?
One.
All the points. So pick a nice, easy one. Any little point would still work, okay? Origin's the best to test because it's the easiest, but if you had a proportional relationship, it'd go right through the origin, right? So, for A, x is greater than 3. It's 3 doesn't work. That's that dotted line. But everything greater than 3 does work. B, y is less than or equal to negative 2. The solid line works, and everything below it works. For C, the line is y equals x. Okay? So I'm just going to start with my y and x. I know it's y equals x. It goes through the origin, so the y-intercept 0 and it has a slope of 1. Now, because it's dashed, it's got to be greater than. Not greater than or equal to. So the line doesn't work. And if you want to test out any point, let's say 0, 6, you can test out any other points. And D is y is less than or equal to x. Solid line that works, okay, because equal to works like 1, 1, 2, 2, 3, 3, and so on. And then everything below it. That's it, guys. So we're going to make sure. If we're given 2 variables, we can determine which side of the line solutions are. They either work or don't work. And we can describe the graph in 2 variables then, by writing the graph.